So welcome to Module 5 of the AppSim training material, and in this module we're going to be looking at 40-year simulation runs of different chickpea sowing rates. So in our previous simulations we've really done quite short-term simulations. In this simulation we're going to run a long-term or a 40-year simulation. The idea is we're going to be comparing two different sowing rate strategies or planting strategies with the goal of maximising yield or identifying which one maximises yield. So in longer term simulations, so the simulation is longer than 1 year, the end of 1 year's simulation becomes a starting point for the next year. And that's really useful if you're interested in seeing degradation within the system or improvement in the system from different management practices. So really good for looking at the longer term impacts of crop rotations or different cropping practices. But if we wanted to work out what the best strategy was for a given year or a current year using a long-term weather file, say the past 40 years, what we could do is create 40 individual single-year simulations. Another option we've got in AppSim is to use a reset function, which resets the soil properties back to the initial conditions on a given trigger, usually either planting or a date that we specify, and that's what we're going to use in this simulation. So we're going to essentially set up a long-term simulation or a 40-year run simulation, which will actually ultimately end up being 40 individual single-year simulations, but the way that we'll do that will make it very simple. So the first thing to do is to open up the AppSim user interface, and it will launch the whatever your simulation you're working on previously. So in my case, that is the material from Module 4. We're going to start a new simulation now, so we're going to click New. And remember that opens up the examples folder, or the simulation examples folder for us. And we're going to scroll down to the continuous wheat simulation and open that up. First thing we're going to do, because we're working on it, starting new simulations, we're going to save it with a new name. So click on Save As, and wherever you're saving your AppSim training simulations to, save it as Module 5. Now we're going to be running a long-term simulation, so we're going to want to change the clock in this case. So click on the clock node, leave the start date as the 1st of the 1st, 1940, but change the end date of the simulation to the 31st of December, 1980. Okay, so now we're creating our 40-year run. Now we want to change the soil over, so in the training toolbox that's down the bottom there, if you haven't got it there showing in your user interface, refer back to the very first module, and that tells you how to bring that toolbox into your user interface. But if you click on that training toolbox, it brings up our folders. One's the soils folder. We want the heavy clay soil, so click, hold it down, drag it up and put it into the paddock. There we go. Now in AppSim we can't have more than one soil in a paddock, so click on the original soil node that we have and hit delete on your keyboard to remove it. Now if you expand out the heavy clay soil node, we'll see our usual child nodes underneath the heavy clay soil node. So click on the water one, and you'll notice here we've got properties for wheat and properties for sorghum specified. Now, in this simulation, we're going to be growing chickpeas, not wheat or sorghum, so we need to actually add properties for chickpeas. So to do that, we click on the Manage Crops button there, and then we just simply add chickpea to the list of crops. And then that creates us a space in this interface here where we can add in parameters. And this would be the lower limit for chickpeas, and then also the KL and the XF factor. Now, XF is the root exploration factor, and it sits between 1 and 0, with 1 being fully non-limited root exploration of that soil layer, and 0 being fully limited root exploration in that soil layer, and which is sort of the equivalent of trying to grow a crop in concrete. The KL factor is the proportion of plant available water that the plant can extract from that layer on any given day. Now, these parameters, the lower limit, the KL and an XF factor, they should be determined experimentally through field experiments on the particular soil that we're working with. However, they only really affect crop growth in the model under severe water stress. So for activities like this analysis we're doing today, it doesn't really matter that we're gonna simply estimate them from the values we've already got for sorghum. So what we'll do is we'll just transfer the values in from sorghum. So select the lower limit values, copy them, and then paste them in. And notice here that the PAWC for chickpeas is then calculated straight away, and that's calculated from the drained upper limit and the chickpea lower limit. And then the KL and XF factors, we just copy them as well from sorghum. So select copy and paste them in. And now we've created our soil properties for chickpeas. There's a few other things we need to change in or add to in the soil in this case. So first of all, we want to set our initial water to being 50% filled, and make sure you got it filled from the top. And then also we need to set our starting nitrogen. So we want our starting nitrogen to be specified in kilograms per hectare. So right click on the NO3 and the NH4 column headers and select kilograms per hectare for both of them to do that. And then specify the starting NO3 as 20 kilograms per hectare and the starting NH4 as 0. Now, this will just currently we're only specifying for the very top of the soil, so from 0 to 10 centimetres, we want to distribute that evenly across the full soil depth. So go back to the water node and take note that the lowest soil depth is 180 centimetres. So go back to our initial nitrogen node and change that 10 centimetres to 180 centimetres. Now that we've got our soil set up, the next thing we need to do is set up our crop management. So we need to remove our wheat crop. So right click on it and select delete. And then we're going to bring in our chickpea crop. So you'll find the chickpea crop under the standard toolbox. And we're going to go to the crops folder. And in here we've got chickpea. So click and drag it and place it into the paddock. Expand out we can close that off. Now expand out the manager folder and select crop management. And here's our interface to specify all our sowing or planting management for our chickpea crop. So first of all, we'll change the type of crop or the name of the crop from wheat to chickpea. We'll specify a start of our sowing window to the 1st of May. Leave the cultivar change date as NA. Specify the end of our sowing window as the 1st of August. Okay, leave must sow as no. Now specify the amount of cumulative rainfall to trigger sowing as 15 millimetres, and we want that received over 3 days rather than 7. And the amount of soil water to plant on as 200 millimetres. Change the cultivar to amethyst. Leave the second cultivar as NA because we're going to sow amethyst irrespective of the date. The sowing density should be, in this case, 10 plants per metre squared. The sowing depth leave as 30 millimetres and the row spacing as set to 350 millimetres. And leave the extra parameters as they are. Okay, so what we actually set up here is that we've specified a sowing window that we could plant the crop within. So we'll plant sometime between the 1st of May and the 1st of August, as long as on that time we're determined by when there's been 15 millimetres of rainfall over 3 days, and if and when the soil water, available soil water, is 200 millimetres. Now, if those conditions aren't met, because we've got must sow as no, the crop won't sow. So we potentially, and as you'll see later on, there will be years where there isn't a crop planted. Now, the next thing we need to do is remove the fertilised sowing rule. So right-click on it and select delete. Because we're sowing a legume, we're not going to be applying any nitrogen fertiliser to the crop in this simulation. And then we also need to bring in our reset option to stop our simulation being continuous 40-year run to 40 individual 1-year simulations. So you'll find this reset manager under the manager folder in the manager common tasks folder. Okay, and it's called, there's two of them. There's a reset, let's expand this out so we can see it properly. There's a reset water, nitrogen, surface organic matter and phosphorus on fixed date, and a reset water, nitrogen, surface organic matter and phosphorus on sowing. They work both exactly the same, other than one is on a date trigger and the other one is on a sowing trigger. We want the fixed date trigger for ours. So click on it, drag it and place it into the manager folder. Now, it's actually the order that managers appear within the manager folder is actually really critical, because this is the order that AppSim will execute them in. What we're doing here as we create our simulation tree is actually creating computer code in the background, and computers being computers, they execute the code in the order that it's given to them. And what we want is actually the reset code to occur before the crop sowing code. So right click on the reset manager, and we just want to move it up to the very top of the manager folder. And if you're ever using these reset options, it's really important to have them at the very start of the manager folder. Okay, now we've clicked on it, an interface opens up, and we want to specify some parameters in it. And is our reset date. So we want a reset date on the 1st of May. Make sure it appears exactly as it does on my screen, because remember, AppSim is really picky about date formats. Okay, the name of our soil module is heavy clay, so we'll select that. The name of our surface organic matter module is the surface organic matter, so we'll select that. We don't have a phosphorus module, but because we're going to leave reset phosphorus as no, that doesn't matter. And we want to specify that we're resetting the water, we're resetting the soil nitrogen, and resetting the surface organic matter. So make sure those three are set as yes. Now, next thing to do now is set up our crop management and our reset management. We need to specify our outputs. So under the output node, expand it out till we get to the variables node. Click on it and delete everything that's in that interface there. So select it all, right click and go delete. And we want two outputs in this case. So the first one we'll find under the clock component, and simply we want year, so we'll double click on that one. And the other one we want is under the chickpea component, and it'll be right down the bottom. We want is yield. So two outputs. Click on the reporting frequency node, and we just want to check to make sure that harvesting is there. So currently we've told AppSim that we want, at harvesting, we want to know the year and we want to know the crop yield. Okay. Now before we run our simulation, we're just going to rename this one to chickpea 10 plants, because it's our 10 plants per metre simulation. And now we're going to create a duplicate of it. So right click on the chickpea 10 plants simulation node, select duplicate this node. We're going to create one duplicate. Okay, and we want to rename that duplicate to 15 plants. Now expand out our duplicate there and get back to the crop management node that's in the manager folder. And because we're doing, this is our 15 plants per metre simulation, just change the plant density to 15 plants per metre squared. Okay, hit save, click on the simulations folder, and then select run. And fingers crossed your simulation runs cleanly without any errors. So far, so good. Now simulations are run. We can click on the output file. No, this is our 15 plants simulation. You see here a run of years and a run of yields. Notice here that not every year has a yield, and that's because we haven't forced the crop to sow every year. If we expand out the 10 plants simulation, click on its output node, again we'll see a run of years and a run of yields. Notice if we click between them that the yields are different. Okay, but we want to visualize this in an easier way to see the differences in yields. So we're going to create some graphs. So click on the graphs toolbox down the bottom, expand out the graphs node, click and drag up the XY plot and stick it into the simulations folder. And while you're here, grab the probability of exceedance plot and stick it into the simulations folder. Close that off now. Now if we expand out the XY plot node down to the AppSim file reader, and then click browse, we want to select two AppSim outputs, the Chickpea 10 plants simulation output and the Chickpea 15 plant simulation output. So to select them both at the same time, click and hold down the control button on your keyboard and select the second one. And now we're brought in two. Click on the plot node then, okay, and we want to specify year as our X variables. Click on the Y variables box to make it pink, and then click yield, the yield column header in the table below. Now click on XY. You'll see here we've got our yields presented. This case is a line graph, but because we don't have year, it's not a continuous yields every year. Probably lines isn't really appropriate. So if we go back to the plot node and change our graph type from solid line to bar, and then click back on XY. And it clearly shows that the difference in the yield between 10 plants and 15 plants in each year, but also note that some years there hasn't been a crop sown at all, and that's reflective of the manager options that we put in place around the crop sowing rules. So looking at it as bar charts, that's one way. The other way we could look at this is through probability of exceedance plots. So expand out our probability of exceedance plot node right down to the AppSim file reader. Again, click on browse and select both the Chickpea 10 plants and 15 plants .output file at the same time. Remember using the control key on your keyboard. Then select the plot node. Leave Y variables as probability of being above. Make sure the X variables box is selected in pink, and then click yield. And then click on the probability of exceedance plot node here. And we'll see here the probability of exceedance for our different planting densities. So our probability of getting above 2,300 kilograms of chickpeas when we plant at 10 plants per metre squared is 0. So that's our maximum possible over those 40 years. But we've got certainly a chance of getting well and truly above. What would that be? That looks like it's more about 1,600 kilograms per hectare. We've got definitely a very good, above 95% chance of getting above that. This is for the 10 plants, and for the 15 plants here, you see here we've always got a greater probability of getting higher yields, and that's reflected back in our bar chart where our yields are always higher. If it'll display, always higher in every year that we've sown. So that's how we do long-term or multiple year simulations in AppSim, a real simple way using the reset rule instead of having to manually run individual single year simulations. Make sure you save your simulation at the end, and we shall see you back here for the next module.